We're recording now. You are good to go.
Excellent. Well, thanks for that introduction. Without further ado, I'm going to share my screen and get this PowerPoint up there. I'd like to thank everybody for showing up tonight. Wasn't expecting all these people to show up, so that's really great. All right, so I'm going to get started here. If you have any questions, we can address them at the end. So if you feel you can just throw them into the chat, the message board, and we can discuss those at the end. But for just the sake of rolling along through this, there's a lot of different topics we're going to be discussing about this spotted turtle, and we can get to all of your questions at the end. I'm very excited to share it. All right, so the secrets of spotted turtles. Spotted turtles are a very unique animal, and we're going to hear a lot about them tonight. So you're probably wondering who I am and why I'm here talking to you about these odd little turtles. My name is John Garrison. I'm a self-titled lifelong wildlife nerd. When I was a child, my parents were constantly taking me out into the wild. My dad was an avid hunter and an outdoorsman, and he would take me out to go horn hunting at our home in Colorado Springs, Colorado. And I would love to go out there and just view wildlife and just learn and view and see what would happen. And many of the times I would find like lizards or snakes and things like that were what I was really interested in. So you can see towards the bottom left here is a picture of me out there as a child with a common garter snake in Colorado. Needless to say, I gave my mom quite the fright just because prairie rattlesnakes were ever so common in the area. Luckily, I never got bit, but those childhood experience stoked an interest in me in the outdoors, and it has continued into my adulthood and will continue through the rest of my life, and has led me to pursue this career of researching wildlife for the purposes of conservation and management for imperiled species and misunderstood species. So I attended Frostburg State University and gained a bachelor's of science degree there in 2019. And during that time, I applied myself to as many research projects as I could possibly. And I had an advisor who was a mammologist. He was a carnivore biologist and used a lot of camera traps. So that really got me interested in camera traps and was sort of the basis for some of the stuff that you're going to see later in this presentation that is represented in my master's thesis work. And I just recently completed my master's research and just got my conservation biology of master's science degree from Antioch University New England, which is in Keene, New Hampshire. I'm glad to be back down here in the mild weather for now of Maryland. And I've got some experience researching various wildlife species, not just turtles. I love all of the critters and creatures, and I hope you do too. And currently I'm the research coordinator at Susquehannock Wildlife Society. We're a nonprofit based in the lower Susquehanna region of Maryland and Pennsylvania. And we do wildlife education, and we also do wildlife research, and we assist in wildlife rehabilitation and rescue with local veterinarians in our area. We have a wildlife center in Darlington, Maryland, and it is a really, truly incredible place, and it will be fully open to the public at some point during this year. So keep your eye out for Facebook announcements, but without any further ado, let's get right into it. Enough about me. So just an overview of what we'll be talking about. Why are turtles so important? What is a spotted turtle? What are they hiding? What are those secrets? And why conduct research on a population of spotted turtles, or anything for that matter? And then I'm going to discuss several studies in which I've taken place of, such as the Susquehannock Wildlife Society's population study, some nesting research in Delaware, and a population study that was taking place throughout the Eastern United States that was led by the Smithsonian and was partnered with the Department of Defense, Partners of Amphibian Reptile Conservation. And all of these studies sort of were in one way or another contributing to the conservation status assessment of the species, which is a huge conglomerate research project that is it's truly a beast of a project, and we'll get into that here in a bit. And then I will talk about my master's thesis nesting study, and we'll likely have some time for conclusion and questions. So, why are turtles important? Well, they're prominent figures in human culture. We all know the story of the tortoise and the hare, and they've represented countless times in cartoons and stories and art and literature, and they're just everywhere. What's not to love about these turtles? They're just awesome. They're very old and they're long-lived. They're long-lived as individuals. Spotted turtles are estimated to live up to over 100 years in the wild in some populations, and that's just incredible. Also, they're very long-lived on this earth. The subfamily Amidae, which is what the spotted turtle is in, evolved in the Eocene epoch about 56 to 40 million years ago. And just as a comparison, the family that we reside in, the Hominidae, we evolved in the Miocene epoch 8 million years ago. So they're very long-lived in multiple ways, and we deserve to keep them around in the landscape. They're high contributors to biomass, and they give off a lot of genetic material, which is cycled through the environment. And they are massive contributors to mineral cycling and bioaccumulation. They're important in the trophic class, both top down and bottom up. They are predator and prey species. They like to prey upon little tiny creatures in wetlands, and sometimes they will even, top down control those. One species of turtle, the diamondback terrapin, the Maryland state turtle, is the main grazer of periwinkle snails. And without the diamondback terrapin, it's predicted that these periwinkle snails would just be everywhere. So yeah, they top-down control ecosystems, and they also have bottom-up trophic implications. So a lot of animals do feed on them, such as raccoons and foxes, and a lot of animals do eat their nests. And, although that may be a conservation problem, due to the high abundance of some of these species in the current, that is, a part of the way things are. So, and what is a spotted turtle? So spotted turtle is a small freshwater turtle. You can see here on the left, they have a mostly black carapace, or the top of their shell, with yellow spots. It's very beautiful. And the bottom is yellow and blotchy, and it has black and yellow blotches along 12 scutes, which make up the plastron, or bottom of the shell. They're easily identifiable due to these spots and their small nature, and they're sexually dimorphic. Here in the top left corner, you will see a female, and they have brighter eyes, and they also have a yellow stripe on their face, which is comparable to the male, which does not have that. They have more darker eyes and a darker face overall. They're a North American endemic species, and they occur in disjunct populations. In the east, they range from Florida and along the Atlantic coastal plain all the way up to Maine, where they reach their terminus. And in the west, they pretty much encircle the Great Lakes, from New York all the way to Indiana and up into Ontario. They are a rare and declining species. As Matthew said, they are listed by the IUCN as endangered. They've been petitioned for federal listing here in the United States, and they are a species of greatest conservation need in every state in which they occur in the United States. And they inhabit shallow wetland systems such as vernal pools and other emergent wetland areas such as wet bottomlands, cranberry bogs, natural bogs, lots of different shallow emergent habitats that they will inhabit. And they're very, very secretive. You could spend a lot of time in spotted turtle habitat and never see one unless you're using the proper methods to capture them, because they like to swim around in the vegetation and in the muck and deep in the water. And some of the water in these areas is quite dark because a lot of these wetlands that they occur in have high organic pack in the bottom, and it makes it quite dark. And they're quite an understudied species in some areas of their ecology and population dynamics, which just is interesting because there are many secrets still to be discovered about this species. So what are they hiding? How many individuals are in a population? There are a lot of different questions you can ask about a population that will tell you many different things. Is the population stable? Is it decreasing or increasing? What habitats do they prefer? Are they active during what time of year? Does activity vary between sexes? And where are they nesting? These questions all lead to different questions, and they just keep going on and on and on. And each question may gain a little bit of knowledge, and that knowledge is to be built on to further inform different studies. And by recreating these different questions, you can learn a lot more about a species. So we should get to the bottom of some of these questions that we have the spotted turtles and some of their populations. Sir Isaac Newton said, "If I've seen further, it is by standing on the shoulders of giants." And that is essentially how science works. You ask a question and then you may get an answer, or you may say, oh, we don't have high enough sample size, we should go back and do this again, get a little bit more understanding of this, apply it to different sites, populations, and you just keep building on and on and on. And some of these questions are interesting, but they also have implications for the management of these species, especially for species that are of conservation concerns, such as the spotted turtle. So is the population stable? Are the nests being preyed upon? These all can be turned into management questions, and management have implications for management, such as, will population augmentation help this? Will Cajun nests help the population? Are humans in the area, are they impeding on the normal functioning of this population? And can we improve the habitat? How can we do this? And will these management practices help out these populations in the long run? So the first study I'd like to talk to you all about is a population study conducted by Hunter Howell and Dr. Rich Siegel at Towson University, and also Richard Legier and David Holland. So I think Hunter's in the audience, so shout out to Hunter for doing this awesome research. So yeah, this is a really interesting study, and this was the first time I ever had seen a spotted turtle, was volunteering on this project. This was the first research project I'd ever been a part of, so it was really enlightening for me. And the first day in these vernal pools out there with the spotted turtle guru, Hunter Howell, I knew that I definitely wanted to be doing this for a long time. And so the study location is in Harford County, Maryland. And from 1987 to 1992, Legier and Holland studied this population. 2014 through 2017, Howell and Siegel picked up this study and continued similar methods, such as using Promar baited sardine traps to capture turtles, mark sex and age the turtles, and then release them, capture them again, and go through the same steps again. These capture, mark, recapture techniques are really great for informing population studies, and you can get population estimates from them and other demographics that are important to monitoring a species, such as age class demographics and age class or sex ratio, a lot of things that are very important for informing management. So the goals and objectives of the study were to use mark recapture to estimate population demographics at our Harford County, Maryland study, conduct a population viability analysis, also known as PVA, and examine the population demographics over 30 years of intermittent sampling, and analyze the efficacy of conservation practices using a sensitivity analysis. So during the course of the study, 255 individuals were captured historically, And then during the current sampling time period, 104 individuals were captured. This represents a 49% decline in this population, with 121 approximate individuals lost. This population is very interesting. It's surrounded by roads completely, and road mortality and low recruitment is likely to blame for the decline, this 49% decline. And to quote Hunter from Howell et al. 2019, this decline was concurrent with a significant increase in the proportion of larger individuals within the population, indicating a lack of recruitment into the sub-adult stage class. So after this, and they saw all these horrible results that were informing that this population was likely decreasing to a point where it would be no longer viable, it's quite sad. And the next thing you immediately think of is, are we able to help this population? And so by opening up the vegetation and doing some vegetation management, you could potentially make the habitat more suitable for nesting and for turtles in general, which could help mitigate the mortality on the roads, as well as installing silt fences along the roads that redirect the turtles back into the wetland. It's important to note that there are no other spotted turtle populations very close to this. So when the populations, or when the turtles are dispersing, they're essentially going out to look for other areas to nest and to hang out and do their thing in, and they're being hit by these cars. And, you know, the end result is population decline. So the population viability analysis was conducted, and here in these graphs, you can see on the x-axis years into the future and number of individuals. Now there is a north wetland complex and a south wetland complex, and both of these complexes were showing similar trends. This is the same population. One of them is north of the road, one of them is south of the road. So on the y-axis, you see individuals, and currently you have 141 a year. And over time, based on this estimate, the population number of individuals goes down as the years progress. And eventually, you will no longer have a viable population if certain management implications are not taken into account to mitigate these risks. So another thing that Hunter found was there was a massive change in age class over time. During the historic sampling, there were individuals of many different age classes, but over time, they became much more older, and it was apparent that there was not a lot of recruitment here in this population. I'm going to talk here a little bit about some nesting research that's being conducted in Delaware. I was a seasonal field tech for the Department of Natural Resources and Environmental Control at Delaware, and was assisting on a population study conducted by Dr. Nate Nasdruix. If you have read the Maryland Amphibian Reptile Atlas, he is one of the main authors on that. And if you have not, I strongly recommend checking it out. It's a great wealth of information on the herps of Maryland, and it dives beautifully into their natural history. So it's a great read and very informative. So this study, I was helping out for about a summer, and we were doing radiotelemetry monitoring of males and females. The females were getting these thread bobbins attached to them, which you can see in the bottom left-hand corner here. Thread bobbin is essentially a spool of thread, and you can tape it to the back of a turtle shell and tie it off to a piece of vegetation. And when you release them, they will do their thing, move through the vegetation as they will, and you can follow the thread and see exactly the intricate movements of every little turn that they have done. And through this, combined with radiotelemetry monitoring and checking on them frequently, you can figure out where they're going, what habitats they're using, with the overall goal of finding nests. If you do this properly, the thread should zigzag through the forest, and when the turtle nests, it will use its back legs, and unknowingly, while it is digging out the nest, will put a bit of thread into the ground. And so when you're tracking these and you find the thread going into the ground, you likely have a spotted turtle nest or any turtle nest that you're monitoring. So this population was a vernal pool complex, and it was adjacent to salt marsh in Kent County, Delaware. And the results were, I'm only going to talk about part of the results of this because, this isn't my study wholly. So just the things that I observed. So the results, we observed 2 nests that were laid into a salt marsh, which was never described in spotted turtles before. It is known that spotted turtles have a incredibly varying nesting ecology. They use a lot of different habitats throughout the vast geographic range that they occur in, and they frequently occur next to salt marshes in the Atlantic coast. However, no one had ever documented turtles going out into the salt marsh and nesting. So 2 nests were laid in the salt marsh. One contained 3 eggs and was about 10.7 meters from the edge and 10.7 meters into the salt marsh. It was laid at the base of a decaying pine tree. All of those eggs successfully hatched, and nest 2, which is here on the right, was way out into a salt marsh, about 30 meters from the edge, 27.7 meters to be exact. And there were 2 eggs laid in the muck in a big Typha, cattail, and Phragmites conglomerate out there in a estuarine wetland, and took water salinity samples 1 meter from the nest, and it was 5.5 parts per thousand. So that's pretty significant. And eventually these eggs were inundated by 6.5 centimeters of tide, and it was determined by Nasdruix and Small that these eggs were unviable. So this is really interesting, and I'm excited to hear more about this study and other studies like this that are examining turtle populations on the edge of salt water, especially as time progresses and sea levels are predicted to rise. It is pertinent that we study the survivability of these animals in this changing landscape. It's really interesting that this one nest was out there in the salt marsh and was still able to be successfully hatched. The other one did not, but it'll be interesting to see these trends over time and determine whether or not, or observe whether or not these are impacting spotted turtles. Another project that was just coming to completion here was the Smithsonian Department of Defense Partners of Amphibian Reptile Conservation Research. Big bold name here, building capacity for managing at-risk species to enable mission readiness at military installations, spotted turtle status assessment and surveys. And so there were a lot of different things going on with this. There we go. So the main authors on this were Thomas Ockery and Jess Meck of Smithsonian Conservation Biological Institute, and there were many other people that helped out in the field, such as myself, Molly Perrin, Dr. Elizabeth Wiley, who was my master's thesis advisor, Lori Erb of the Mid-Atlantic Center for Herpetology and Conservation, and Houston Chandler, the Orion Society. So the overview of this study was to determine the population distribution and abundance of these turtles on military bases throughout the eastern United States. And we wanted to evaluate habitat management opportunities on these military sites to inform potential management and the readiness that was available for these areas from the military installations themselves. And so 9 military installations were sampled in 5 states, ranging from Georgia to Massachusetts. I was sampling Camp Edwards on Cape Cod, which is the largest protected tract of land on Cape Cod. It's incredibly beautiful, and I was felt very privileged to be on this land. It was really, really interesting going out to a spotted turtle population where that very, very few humans have been in the last 200 years since it's been a military installation. So it was very interesting to see this population in a pristine pitch pine forest back in a protected area, and not just a protected area, but a off limits area to civilians. So it was really, really quite special. And I did learn a lot. So turtles were captured in baited crayfish traps following Wiley et al. 2022, which is the conservation and status assessment. These are similar methods to what Hunter was using in the Susquehannock spotted turtle population assessment. These are little Promar traps, put some sardines in there, and you set them out for 5 nights at a time. You check them every day, and you do surveys intermittently. So we did a couple surveys, 5 days in April, 5 days in May, and 5 days in June during 2021. And these sampling dates did range between all of these months, but were varying over the geographic distribution in which they took place. For example, in Georgia, they were sampling a lot earlier than we did in Massachusetts because it was very cold. They were starting in early April. We were starting in late April, just because of the temperature difference. And that's just a testament to how interesting these turtles are. They have such a vast range, and throughout this range, they're subject to so many different environmental conditions. And that's one of the reasons that make them so interesting, and why they have so many secrets to them, and definitely more secrets to be explored. So here is some pictures of the habitat in Camp Edwards. Up in the top left, labeled A, is a northern type bog, mostly cranberry sphagnum bog with pitch pine growing out of it. And there were little channels through this that we were setting traps to catch these spotted turtles. Just on this military base itself, you could really get the understanding of how much variety in habitat these turtles use. B, we go over to B, and the turtles are using the edges of ponds and flooded emergent wetlands. And C, we have a natural cranberry bog, which is where a lot of the assessment took place, and most of our captures took place. It was really, really interesting to be back there, just walking around. You could just walk along this giant floating mat of cranberries and sphagnum, and reach down, grab a spotted turtle, and then reach down and grab a cranberry and have a little snack. So it was very interesting in that regard. And D was a typical vernal pool emergent area. So these were seasonally flooded wetlands, and they were very full of emergent vegetation. So that's just an example of how much habitat varies between even one site. So across the range, you can imagine all the different types of habitats they're using. Hence why these large projects are important, because you can figure out, what exactly they prefer. And so the sampling method is described here in the upper right-hand corner. It had different centroids, and this is what all of the different installations were doing. This is the methodology we're following, and this is from the methodology for the conservation status assessment. So all of the states from Georgia through Maine were using similar methods to this, which I will talk about here in a little bit. And results. So at all 9 sites, there were a total of 2,085 trap nights. There were 213 captures of 179 individuals, which is quite a lot for 1 year of sampling. Mean catch per unit effort between all 9 sites was 0.169 with a standard deviation of 0.149. Catch per unit effort is essentially taking the number of trap nights and dividing it by the number of trap checks, and or it's the number of trap checks divided by the number of captures, which tells you how likely you are to find a turtle per trap check. So if you go out 0. So every time you trap a check, or every time you check a trap, you have a 0.169 chance of likely catching a turtle. If you were expected to catch a turtle with every trap, the mean catch per unit effort would be just 1. So the results just for Camp Edwards were very unique. There were numerous juveniles. It was quite incredible. Lots of hatchlings, as you can see here on the right. And there were very low recapture rates, which might indicate that there are a lot of individuals in this population. The vegetation was very thick, and there were lots of areas for them to hide. They could go down into the sphagnum and be in this giant mat of sphagnum moss and not be seen again. So it would be really interesting to conduct this research further and get a better idea of what the population estimates are at the site. So I conducted 316 trapped nights here, and that resulted in 50 captures of 47 individuals, and with a catch per unit effort of 0.158. Plotted estimation, abundance estimations were calculated in R using the R capture package for all of the different 9 sites. Here you can see the installations on the left, and on the x-axis you can see the abundance estimates. Camp Edwards, which is where I was sampling, had huge standard error, and abundance estimates were 158 individuals. But with the huge standard error, it's really hard to tell just because there were very low recaptures. So it was hard to really get an accurate reading of how many turtles were here at this population. So if you take that data point out, you can see that the population estimates for all of the other sites are more accurately represented. And they range from 5 turtles, the abundance of 5 turtles at Fort AP Hill, to about 72 turtles or 82 turtles at Northwest Annex. So they ranged in population estimates and also by state. Now, the conservation status assessment is this very large project that I've been talking about, where all of these different projects basically report to. If you are a state agency, you've probably heard of this. Essentially, you go out and you use the methods I've been describing, where you make these centroid areas, put big circles on GIS, and then you go and set a set number of traps per those, and you check them a certain amount of times throughout the year. And all of that data gets combined and has been assessed in this status assessment and conservation plan for the spotted turtle in the eastern United States. And this is just a beast of a document. It's recently been published at the end of 2022, and it's about 285 pages long with 16 chapters. Essentially everything that is known to science about spotted turtles you can find here, and everything that we would still like to know as scientists is also reflected in here. So I was lucky enough to help out as a research assistant on this project as the lead author. One of the lead authors, Dr. Elizabeth Wiley, was my thesis advisor. So I was working with her to help with the ecology chapter and the population estimates using capture mark recapture chapter. So the conservation status assessment ecology section, essentially I was tasked with doing a comprehensive literature review of all of the scientific literature out there so that you can start to formulate a chapter, a document about all we know about spotted turtles. So it took countless hours and hours and hours reading, and finding more papers to go after. More papers turned into more papers. You look and you're like, oh wow, that's interesting. I didn't know that this author also worked on spotted turtles. Let me see if they have anything else. And then you fall in the rabbit hole of, wow, this is more research that I should be looking at. And then you get into their citations, the studies that they have cited, and then you say, oh, wow, that's an interesting study. We should probably incorporate that into the plan. And you end up with a lot more studies, and you essentially just keep reading and reading and reading until you fall asleep. No, I'm kidding. But eventually you have enough information to inform a chapter about the ecology of a turtle once you have compiled all of the known scientific literature and in a document. So this chapter 2 or chapter 1, the ecology of the spotted turtle, has several subsections. I really hope that everybody goes and checks this out. It's free for download on northeastturtles.com, and it is just a great document that outlines pretty much everything about the spotted turtle we know. The ecology has different subchapters: summary, all of the habitat, which is very varying throughout the range, all up and down the eastern United States. Goes into their activity seasons, their life history, compares population demographics by region and by state. It goes and takes a deep dive into the threats and what we think are the most pervasive threats to the species. How could we possibly mitigate these threats through management? And it gets into their legal status throughout the different states, and just basically lays all of that out. There were incredible amount of people that helped out on this chapter and helping inform a good overview of the ecology of the species, which are listed in the right here. And chapter 7 of this was the population estimation of spotted turtle sites using capture mark recapture methods, which I have talked about previously. And so we used RStudio to calculate population estimates using log linear models, using the RCapture package. And we used the regional sampling database. So all of the states in the eastern United States who took part of this study were submitting to their state lead. The state lead was submitting to the national lead, and then the national lead has a national database and use that database to look at all of the populations of spotted turtles and conducted these population abundance estimates. Most of these studies, most of the sampling periods took place over 1 year, and we assume a close population because of this. We include any site in our analysis that has greater than or equal to 5 turtles with at least 2 recaptures, because we wanted to include as many populations that we could into this. And so 80 sites may meet the criteria for this analysis. Population estimates were calculated using the RCapture package by Revest 2012. And we displayed graphically the results using ggplot2 package. And we would like to determine catch per unit effort, compare by region. And this is a really unique study because it allows for long-term monitoring, a baseline for long-term monitoring over a vast area, 80 sites to be specific. So the results, over here on the right, we divided all of the different states and populations into 3 different subregions. So in yellow, you can see New England. The Mid-Atlantic is highlighted in blue, which is shout out to Maryland. And then we've got the Southeast in orange. And these were pooled as different regions. And population estimates range from 6.8 individuals to a study in Delaware to 414 individuals in North Carolina. And they varied by region. The highest median estimates were in the Mid-Atlantic. So out of all of the Mid-Atlantic studies, the median estimate was 60.3 individuals, followed by the Northeast, where the median population estimate was 49.2 individuals, and the lowest median estimates were in the Southeast, which was 43.8 individuals. So it'd be really interesting to build upon these and, continue to sample these. The next time this grant is up, they will be resurveyed, hopefully, and we can build on these population estimates, have more reliable estimates, and monitor the trends over time, which is really interesting and can inform whether populations are declining, increasing, they're becoming stable, and can sound the alarm if management strategies are needed. And so here's a look at our population estimates. On the x-axis, we have abundance estimates and sites on the left. And the sites are all categorized by state code, such as West Virginia's WV, MA is Massachusetts, and then they all have a letter representing the population. So Mid-Atlantic is all red, the Northeast is all green, and the South is all blue. And you can see the trends described above with the median abundance estimates sort of make themselves out visually here. And the abundance estimates sort of together. All right. So I just conducted my master's thesis research at the Antioch University New England. And this was quite a interesting study for me and combined a lot of my research interests from undergrad, working with Hunter and working with Susquehannock and working with all these different turtle species. I really wanted to do a master's thesis about spotted turtles because that's one of the species near and dear to my heart. But I also wanted to focus on the broad community of predators and non-predators, and that was likely based off of the research that I was seeing from my advisor, who was a carnivore biologist at Frostburg. So that's sort of the informing of this project. And so the study objectives were to characterize nesting phenology, which is the nesting and hatchling emergent states and incubation periods for a site in southeastern Massachusetts. I wanted to describe the mean clutch size and percent hatch success, describe nest site preferences on a macro-micro scale, compare microhabitat of observed nests with random points using conditional logistic regression. We also wanted to describe the predator community, all species at the nest sites, and human recreation that was taking place at these nest sites. And we wanted to know, does distance to edge determine visitation? Does nest investigation vary between predator species? Do humans pose a threat to nesting spotted turtles? And these results can inform management and can also inform other studies. So our study location took place in Bristol County, Massachusetts. And this is a basic schematic of what the area looked like. We don't report our location because many turtles are being collected and sold in the illegal trade. And we definitely did not want our research to contribute to such actions. So we have withheld these locations. And it was a 3-kilometer stretch of power line right away that was surrounded by over 10,000 acres of forested wetland, industrial development, and beyond that, residential housing. And we chose this site because Massachusetts Division of Fisheries and Wildlife had noted that there was spotted turtles nesting there along this power line quite extensively previously. And the study took place during 2021 and 2022. And just to dive into this a little bit, the forested wetland basically was the edge of the power line right away. So you have this huge cut of land through this large contiguous forested wetland. And then on the edge of the forested wetland into this right of way, it basically turned into scrub, shrub, and emergent wetlands all the way up and down for over 20 kilometers. However, our study was just confined to this 3-kilometer section. And in the middle of the power line right away, sort of central to the cut, was this large berm. And it is situated above the water line. So if you walk down from the berm, you get into water. Turtles would come up and nest up on the berm for their eggs to be out of the water, apparently. And there were large clearings along the edge that contained these power line transmissions. So we conducted visual encounter surveys here that consisted of showing up to the nesting site just before dark every night throughout May and June, which is the expected nesting season of the spotted turtle. And during this time, we were walking around and looking for turtles in any elevated area of the power line right away. So we were walking the trails, we were walking the clearings, we were walking a little bit into the water to see if there was any, like little islands where turtles could come up and create a nest. So we were searching all of those areas and we were looking for turtles. If we found a turtle that was not actively nesting, we would record the morphometrics, which is the body size, and we would and sex the individual to see if it was a male or a female. We would palpate the anterior to the hind leg, which is essentially just feeling right above the hind leg to see if there are any eggs in there. That's how you determine whether a turtle is pregnant or gravid. And yeah, so we would do that for turtles that were not actively nesting. And if they were not actively nesting but gravid, we would attach a cocoon thread bobbin to them, which is what I described earlier in the Delaware study. And we would tie that off and check that every 24 to 48 hours. If the turtles were actively nesting, we would take a picture of them immediately so that we would know where the nest site was, and we would continue surveying. We would take a flagging tape and flag the area, but we did not want to disturb the nesting females. So we made sure to keep an eye on that area and keep checking it throughout the night where the surveys were, while the survey was going, and monitor the progress of the nesting female. And once the nesting had taken place, we would cage the nests to prevent depredation. We wanted to try to ensure that these cages would make sure that the predators would not come and eat all of the eggs, because we're really concerned about the population and would like to boost recruitment here if possible. And once the cage was set, we would install camera traps less than 4 meters away from the nest. We used these Bushnell low glow cameras and put them in bear-proof cages, which were mostly to deter people from stealing them and breaking them with like a bat or something. And we locked them to the nearest piece of vegetation, such as a shrub, or if they were near a power line and a clearing, we would attach it to the tower itself. They were all above. All of the cameras were set 1 meter from the ground and at about a 75-degree angle facing towards the nest, which allowed for a wide but concentrated view of the nest area. We didn't want anything to be anything walking by to be captured. We wanted just like a small area, so that we weren't getting a lot more than we were bargaining for, and possibly overrepresenting our data set. So here's these pictures here kind of represent those methods. Here you see this white-tailed deer grazing right next to this nest cage that is located in a clearing. And so we conducted a habitat analysis on the microhabitat level, which you can see up here in the first image in the center of the slide. So we had a meter squared PVC frame that we'd place with the nest in the center, and we would visually assess all of the cover type, all of the ground cover types within that area, and put them into categories. Was it moss? Did we have 10% moss? Was it 100% herbaceous vegetation, bare soil, gravel? what cover types are these spotted turtles looking to nest in? And then we compared those to random points. And random points were found by following Brad Compton's 2008 wood turtle work. Essentially, you use a random number generator to tell you how far you're going to go. So we wanted to keep the search area pretty close to the nests. We didn't want to be comparing our observed nests to a random point that was 200 meters away. So we kept it the random number generator between 1 to 10. And you would get a random number, produce it from this app on your phone, and then you would follow the seconds hand of clock randomly. So you would get your random number, look at the clock, wherever the second hands is pointing, that is your random bearing. So if you got a 7 from your random number generator and you got a 6 while looking at your clock, you would take 7 steps directly south of you towards the 6 direction. And then you would take that PVC frame, and place it right there, and then do the same sort of ground cover type analysis of quantifying the ground cover types so that they can be compared to the observed nests. And these nests, we kept them caged throughout the incubation season. And after 100 days, we would pull the nest cages and excavate the eggs, following Refsnyder et al. 2022 to see the fate of the nests. It is important to note that during the late summer, we were concerned about turtles possibly emerging from these nests and getting trapped in the cages. So we cut large slots out of the cages so that if turtles were to emerge, they could do so at will and safely. And we had no issues with this. They all dispersed freely as they will. And so data analysis, we followed the data organization for the camera trap study following Sanderson and Harris 2013. Files were renamed using the Renamer Lite software and reviewed manually using EXIF Pro software, which we tagged the photos with species tags. And essentially we would review the photos, and whatever was to come along in the photo, if it was a bird, give it the tag bird. If it was a raccoon, we would give it the tag raccoon. If it was a human, we would break it down into 5 different categories of how they were recreating. If they're riding an ATV, they got the tag ATV, or dirt bike, cyclist, hiker, or car, because unfortunately we had lots of motor vehicle use in this area. And metadata was extracted using EXIF Pro software as well. So essentially you pull all of the data from the photos, and it comes into an Excel spreadsheet where you can then analyze the data easily. All analysis were performed in RStudio, and we calculated descriptive statistics for nesting and hatchling emergence dates, incubation period, clutch size, and hatch success. We used the R package survival to conduct our conditional logistic regression using the function clogit. And we used the R package mu-min to calculate AICC values, which is pretty much a correction for small samples. It's pretty similar to the AIC value, but it's just a correction for small samples. And this is the Kiki's information criterion. And we calculated distance to edge using ArcGIS Pro. Shannon Wiener Diversity Index was calculated at each camera trap. So we would have the number of species detected, put it into our statistical analysis through the R package vegan, which would then use the function Shannon Wiener to get our diversity indexes and then we compared diversity indexes by nest. And additional analysis is listed in the upcoming slides. So the nesting demographics, here are the results for that. The nest initiation time varied significantly. Most of the nests were constructed after dark. Some of them were not, but here in the top left, you have nest initiation time, nest completion time, and minimum nesting time with the minimum, maximum, and median values. So the nest initiation was the first time we observed these the turtles nesting. So 1727 hours was the earliest nest we saw ever. And then the median was at 1957 hours, and the maximum was a turtle that we found nesting at 1:47 a.m. While protecting other turtles' nests. We had searched this area many times just throughout the night. We were there for over 6 hours, and then randomly at 1:47, the turtle shows up and starts nesting right there. And so that was kind of interesting. And then we would stay with the turtles, stay in the area all night, monitoring them intermittently, but we made sure not to try to impede on their nesting behavior. And nest completion time also varied. And then we have the total nesting time, or minimum nesting time, because when we found these turtles, we assumed that that's not exactly when they started nesting, although it could have been very close to them. So the minimum time was 27 minutes. And that one was pretty on the spot. I found a turtle around 1700 hours and captured it because it was not actively nesting. And as soon as I released it, it started nesting. And within 27 minutes, I came back and it was pretty much done. It dropped all of its eggs and was leaving. And it was pretty incredible to see that happen so fast. And the maximum was 10.53 hours. It was really crazy. We had turtles that would start nesting at 7 p.m. and then they would dig out a nest and stay with that nest pretty much all night without dropping their eggs. And then as sunrise would come, they would drop their eggs and get out of there. So 11 hours minimum time. So around 12 hours from possibly. Nesting date, the earliest nesting date we saw was May 30th. And the latest was June 28th. And the earliest emergence date was August 22nd. And the latest was September 12th. And the incubation period ranged from 68 to 99 days. And clutch size ranged from 3 to 6 eggs, with a mean of 4.31 eggs per clutch. We determined the amount of successfully emerged hatchlings when we excavated the nests. So if we had walked up to a nest cage and we saw that the nesting cavity has been protruded, then the turtles had started to disperse. We would go and then excavate the nest and count how many eggs were in there. Some of them were unviable, some of them would hatch, some of them would be destroyed, and we would take note of that. And success rate varied from 0%. So that would be a clutch of however many eggs from 3 to 6, none of them making it, to a maximum of 1%, one rate, and that would be however many eggs that was, all of those eggs making it, with a mean of 0.56 success among all of the nests. And here in the middle left, I have just the descriptive statistics for the morphometrics of these turtles. And you can see that they were mostly pretty tightly bound. For example, plastron width ranged from 57 to 67 millimeters, and carapace height ranged, CH ranged from 39.31 millimeters to 50.37 millimeters. Yeah. And our results for mean clutch size were similar to other studies. They were most similar to a study conducted recently by Ref Snyder et al. 2022 in Ohio and Michigan. They had a mean clutch size of 3.71. Ernst in 1970 had a mean clutch size of 3.58 in Lancaster County, Pennsylvania. Lithgus and Brooks conducted a study in Ontario, and they had a larger mean clutch size of 5.3. And then studies further south, such as Lithgus and Mauzo in South Carolina and Chandler et al. 2022 in Georgia, had smaller mean clutch sizes, such as 2.8 eggs per clutch and 2.1 eggs per clutch. And it is hypothesized and supported pretty well that spotted turtles have a varying nesting and reproductive ecology throughout their range. For example, as displayed by these mean clutch sizes, the turtles in the north have larger clutches. The turtles in the south have smaller clutches. However, the turtles in the south, such as Georgia and South Carolina, they could lay multiple clutches per year. They could lay from 1 to 3 clutches per year, whereas turtles in the north, such as Ontario, are only laying 1 clutch per year with larger amount of eggs in that clutch. And results of nesting habitat. So we estimated shrub and herbaceous covers visually, and which ranged from 0 to 75% at all of our nests. So it ranged pretty significantly. They were nesting in various amounts of shrub cover as well as herbaceous cover. It seemed like they really liked herbaceous cover. A mean herbaceous cover was 61.67, so they liked a significant amount of this vegetation, but not a ton of it. And when we conducted our conditional logistic regression, comparing our observed nests to random points, we have the outputs of that analysis here in the bottom left. But I'm going to take a second up here just to show you what some of the spotted turtle nesting areas looked like. So they were nesting in areas of a lot of dead vegetation. Here in this top left corner, we have a spotted turtle with a thread trailer on, which is kind of funny. We captured this this female the night before, put a thread trailer on her, and then the next night we found her actively nesting. So we didn't even have to follow the thread, but you can see how that method works. When they're digging up the nest, the thread will lay in there, and eventually you can follow it and find the nests. And in the top right, there's a turtle nesting on a trail edge, just going after it in a lot of alive vegetation. But it was nesting in an area with a lot of gravel and bare soil. And then in the bottom left, we have a spotted turtle nesting under dead vegetation and in an area of moss and lichen, high amounts of moss and lichen, and high amounts of bare soil with low gravel. And then this turtle in the bottom right corner was nesting in mostly just dead vegetation and live vegetation. There wasn't really a ton of diversity there. And then so if we look at this chart here on the left, we can interpret these these odds ratios and the coefficients of variance. And essentially all of these different cover types will predict whether the spotted turtle is less likely or more likely, not more or less likely to nest there. But if you have a negative coefficient, the turtle is less likely to nest there as that cover type goes up. So it's a little confusing, but as herbaceous vegetation goes up, spotted turtles are more likely to use this area. Conversely, as gravel, which has a positive coefficient, goes up, turtles are less likely to nest there. So overall herbaceous vegetation, bare soil, coarse woody debris, and moss lichen. Higher values of those were associated with nesting, and less gravel and dead vegetation were conversely found. Yeah, so it's important to note that these findings are not very significant. None of the p-values were less than 0.05. So these results here are interesting, and they can inform other studies and compare other studies to this study. However, they're not significantly or statistically significant. If we were to increase the sample size, get a lot more nests, and repeat this or conduct it for several more years, they might come out a little bit more significant. So we recommend more studies take place, using this sort of conditional logistic regression to really get to the bottom of this. And getting into the camera trap research, we detected 6 different species of predators during our study. The most numerous was northern raccoon, with a maximum of 27 detections per 1 camera. And then we had a bobcat was also detected during our study with a maximum of 3 detections per 1 camera. Coyote, 32 detections per 1 camera. Dog, 45. Dogs were very numerous, lots of dogs off the leash. And I wasn't really expecting them to be, just like sniffing nests and just really hanging out around these nest cages. We detected a lot of fishers, but not as many as dogs, coyotes, or raccoons. And we detected several long-tailed weasels, 4 per 1 camera. And we reviewed all of the pictures, and we described whether the animal was investigating the nest or passing through, based on the photo itself. So in all of the photos, you can see the cage and you can see the animal. And if the animal was visually affixed towards the cage or tampering with the cage, we would consider that investigating nests. And if the animal was just passing through, as this fissure is in the bottom center, we would consider that passing through. And so all in all, we had raccoon with the highest amount of nest investigations, followed by domestic dog, and then bobcat, coyote, and fisher. And we had no instances of long-tailed weasels investigating nests. And we wanted to know, is raccoon behavior different than other predators? So we conducted a chi-square analysis. And here are just pictures of different examples. To the right, we have 2 images of raccoons, which we considered passing through. We have multiple pictures of these, and they're just like passing through the area. Didn't really seem to pay much attention to the cage itself. And to the left 2 cameras, these raccoons were certainly interested in the cage and in the nest. So that would be instances where we would consider that investigating nest. And we wanted to compare whether the raccoon behavior was different from other predators. So we took that investigation ratio from the previous slide, and we calculated chi-squared analysis. And we found that raccoon and dog and coyote had significantly different investigation ratios. So raccoon was much more likely to investigate a nest than dog or coyote. However, the results for fisher, bobcat, and long-tailed weasel were insignificant. So they were similar, not dissimilar from the raccoon. However, all 3 of those species had a lower sample size in our data set. So further research would be needed to really determine these relationships. We wanted to know, do predator detections vary throughout the year? And here using ggplot, we plotted the amount of number of detections, the count on the y-axis, and on the x-axis we have the month. So 6 is June and 9 is September. And we have the tags of the species over to the right. And if we start out with the raccoon, we can see that June was the most active season for raccoon. We had the highest amount of detections during June, about 73. And in July, they seem to plummet and come back up in August, and most of the species trickled down in September. However, domestic duck did not. There was a lot of hiking going on in September, so that was quite interesting. But this graph really tells a lot about the nest cages. There's been quite a bit of talk among turtle researchers and about whether you can remove the nest cages. And there's been a lot of research on this, whether you can remove the nest cages after like 30 days, because there's no longer any scent trail from the turtle there. Some people think that. However, our study shows that the predators are still in this area during this time. That doesn't necessarily mean that they're going to be coming after these nests, but they could still be investigating nests throughout this time. And the predators were active throughout the whole incubation season up into September. So that's very interesting. We also wanted to know when northern raccoons are most active. And so on the x-axis, we have hour of day from 1 through 24 hours. And on the y-axis, we have the number of events or triggers of these raccoons. So the dots represent the values observed. So if you go up from number 1, we've got 20 raccoon detections for 1 a.m. And then that's plotted all the way out through 24 hours. And we have a line of best fit that basically shows you the trend a little bit better about when the activity of raccoons are. So this shows that raccoons are pretty much not active, which is consistent with the literature. And it's kind of not best for spotted turtles because they mostly nest during the night. So we didn't really examine this. They might be more prone to raccoon interactions while nesting because they're a nocturnal nester compared to other species like painted turtles who mostly nest diurnally. So that would be another research project that someone could conduct to further parse out those relationships. And we wanted to know if raccoon nest investigations varied from each nest. So we not only calculated the nesting investigation ratio for all of the nests, which we saw earlier in the previous slide, but we did this for every single nest. Basically, it was taking the number of total events, dividing it by the investigation, you get your investigation ratio. And we see here that it varied significantly. Nest N here had only 2 coyotes detected, or 2 raccoons detected, and both of them were passing through. Whereas Nest O had only 1 event of a raccoon, and it was investigating a nest. And then we have Nest E, where there were 10 nest investigations and 5 passing through with the total number of events of 15. So it varied really significantly through from nest to nest, and we wanted to know were there any environmental parameters like influencing this. And we got a lot of non-predators in this area at these spotted turtle nests. We detected 240 birds, 12 snakes. That was kind of interesting. 318 instances of deers, 7 turtles. They were all eastern painted turtles, 4 chipmunks, 23 rabbits, 4 red squirrels, 3 groundhogs, 3 unknown small rodents, and 12 unknowns, which are represented here above and yeah, this would be a prime example of something you can't really identify the species in the bottom right-hand corner, where something's just running through, you just get a glimpse of a tail or something. It could be a coyote, it could be a dog, you never know. So better to just label it as unknown instead of, putting it into something which it may not be. We also detected a ton of birds. This is a pretty neat picture of a great crested flycatcher, just essentially selfieing like right into the nest cam. And then gray catbirds were ever present in this study. They were everywhere. When I was doing surveys, you show up and just hear them calling all the time. They would hang out on the nest cages, and they're always in the nesting area. Lots of blue jays and apparently one headless turkey. Yeah, and so we also detected lots of human recreation in the area. This area is public domain. However, ATV use and car use, dirt bike use is not allowed here. It's illegal in this area. So we detected lots of hikers, 493 of them, 260 instances of ATVs, 84 dirt bikes, 134 cyclists, and 41 instances of cars. And you can imagine that this might not be the best for turtles nesting. If there are people coming up while they're trying to nest, that could potentially scare them away and cause them to choose another nesting area. And things like dirt bikes and ATVs and cars could really, crush a nest. And we had 2 of our nest cages that were struck by a pickup truck during the incubation season, and the nest success of that particular nest was not the best. Only one of them hatched in one of the nests, and another one, the other nest that was struck by the truck, all of them successfully hatched somehow. So we really would like further studies to be conducted on the human recreation of and its implications to turtle nesting, and whether they really pose a threat to turtles nesting, and how can we mitigate these risks if they are posing a threat to these turtles. And we wanted to know, does human recreation vary throughout the year? And it certainly did. July was very active for New England people going hiking and riding ATVs and their bikes and everything. But it was pretty persistent throughout the incubation season. And here we get into some of our hypothesis testing. So the top left table, we have t-tests that were run, and we have the subset on the left with the X and Y variable. So we wanted to know whether macrohabitat type has an influence, or whether macrohabitat type and the Shannon-Weiner diversity index of a nest are related to each other. So we performed those with the subsets human recreation, predators, and all species. And we found that macrohabitat type did not predict Shannon-Weiner diversity index for predators or all species. However, it did for human recreation. And also we tested the number of events or pictures of these different subsets for human recreation, predators, and all species. And we wanted to know if macrohabitat is related to the number of events. And similar to the results above with the Shannon-Weiner diversity index, all predators and species was not predicted by macrohabitat type. However, human recreation was. And this is probably explained by humans like to stick to trails most of the time. And there was a big central trail going through our area of study. And so that's consistent with other studies and just logic in general. However, the predators and all species were able to roam throughout the power line, which is why we likely don't see that that correlation between those variables because they're just doing their thing, moving throughout the power line. And then we conducted Spearman's correlation tests to see whether there was a correlation between the number of events and the distance to edge, which was calculated using ArcGIS Pro. And we tested this for predators, the subsets predators, all species, and human recreation. And we found that predators was not correlated to distance to edge. However, all species and human recreation was. And then we also tested the nest success ratio to the number of events and for the subset human recreation. And we found that there was a significant correlation between those variables. Raccoons, we used the raccoon behavior ratio and wanted to test whether there was a correlation between distance to edge, and it turned out that there was not. So essentially, wherever these turtle nests were and the raccoons were showing up there, it didn't really matter how far they were from the edge. They were still checking out these nests. Takeaways and limitations of the study. So our study measures the detections and behavior of predators rather than natural predation. Our statistical analysis was limited by our sample size of 18 spotted turtle nests. If we had more years of sampling, we would have more nests to use in our statistical analysis, which would allow for more powerful statistical analysis. And the nest cages may influence the behavior of predators during our study. However, this is sort of debated in the scientific literature. Some studies report that the nest cages did not cause more predator visitation, and some report that they do cause more predator visitation. So more studies are needed to determine whether or not there's a relationship there. And our study likely does not represent all spotted turtle populations, just because, you know, we are studying one population in Massachusetts in a power line. And as I've sort of explained throughout this presentation, the ecology of the spotted turtle is highly variable throughout their entire range, which is very, very broad, very, very large range. If you think back to just the habitats at Camp Edwards, they were very different. 3-4 different types of wetlands that they were using, and likely 4 different types of nesting habitats at those sites. So yeah, more studies should take place in different places throughout the range and vary over time to see and better understand these relationships. During our 2-year study, we located 18 spotted turtle nests and observed nesting between 30 May and 28th of June, with the median nest date of June 8th. Hatchlings emerged during August and September, and incubation period was, the mean incubation period was 80 days, plus or minus 8 days. Clutch size ranged from 3 to 6 eggs per clutch, with a mean clutch size of 4.31. 66.7 of nests successfully hatched, whereas 22.2 failed to hatch and 11% became destroyed. We observed nesting along trail edges and clearings, and nests were associated with herbaceous vegetation, dead vegetation, bare soil, and gravel, though these differences between nest sites and random points were insignificant. And if we were to increase our sample size, we might be able to parse out these relationships a little bit better. The results of the study have many applications for the management and creation of nesting sites, and can inform other studies in the Massachusetts area, such as the nesting phenology can really inform other studies, and incubation and hatchling emergence states can really help inform other studies so that people can be out there when they need to be out there. Like if you were going to conduct a hatchling study and you wanted to collect hatchlings and radio track them, it would be really helpful to know when spotted turtles are likely to hatch in Massachusetts. So some of the data that we have provided could definitely inform some studies like that. And we compiled over 250,000 photos in total. However, 3,643 of them were positive detections of vertebrates, and the rest were just mostly wind triggering the cameras. We detected over 16 vertebrate species and 5 types of human recreation activities taking place, and 6 different species of predators at this nesting site. The number of events of predators in all species did not vary by macrohabitat type or the distance to edge, whereas human recreation activity was more likely to be detected further from edge, which makes pretty good sense. You know, humans like the trails, animals not so much. Northern raccoon was the most frequently detected predator species with the highest number of nest investigations, and was significantly more likely to investigate nests than other predator species. The northern raccoon was also primarily nocturnal, and nest investigation rates did not vary by macrohabitat type or distance to edge. Nest success did not correlate to the number of events for predators, humans, or all species. And our study reveals a broad look into the community ecology of vertebrates at spotted turtle nesting sites, and raises the concerns for human recreation and its potential influences on inhibiting the natural nesting of turtles. And we suggest more studies take place looking at these variables so that we can really understand, which predators are the main predator of these nests, whether predator exclusion devices should be installed and kept there throughout the incubation season, and whether predator management is an effective way to mitigate nest depredation at these sites. And so that was a lot about spotted turtles. And so we discussed a lot of things, such as why are turtles important? What is a spotted turtle? I hope you guys know what a spotted turtle is by now. If you don't, then I'm pretty sad. And there are many secrets to be had about these populations. And we discussed a variety of studies, including my master's thesis research, the conservation status assessment, Smithsonian Department of Defense Partners of Amphibian and Reptile Conservation Study, Delaware nesting study, and the Susquehannock Owl population study. I really encourage you guys to seek out these studies and check them out. It's really interesting. And yeah. And conclusions and questions. You can contact me. Feel free to contact me or follow me on ResearchGate to stay updated on my publications. And if you're interested in hearing more about Susquehannock Wildlife Society, check out the website, or when we are open to the public here in the upcoming future, come by to one of our events. We're still conducting events in the meantime, so keep an eye out. And thank you to Matthew and the Maryland Natural History Society and the Herpetology Club for having me. I appreciate it.
Yeah, John, thank you. Much appreciated. In the interest of time here, I think I'm just going to highlight 3 questions that have come up in the chat. First of all, how rare are these turtles? How likely are we to find one without getting any geographic specifics? And then there was a question about the size of their range, like how much do these turtles wander? And then finally something about brood size. Is it true that the northern populations of the turtles have larger clutch sizes than the southern? I think that was prompted by some of the data you were showing.
Okay, so the first question, how rare are these turtles and how likely are you to find one in Maryland? They're definitely around in Maryland. They're a native species to Maryland. I believe they're a species of special concern. So we don't really publicize the locations, but from what you've learned from this study, you should have or from this presentation, you should have a pretty good idea of what these habitats look like. You're looking for low-lying, shallow emergent vegetations, possibly a lot of vernal pools, And yeah, so if you're in the right habitat and you're looking around, you know, you might find one. And then the other question about the clutch size, from there have only been about 5 or 6 studies on the nesting ecology of spotted turtles. There are others being currently conducted. But from what we can tell so far, it does seem that the turtles in the northern portions of their range, such as in Ontario, Ohio, Michigan, have higher clutch sizes, up to 5 eggs per clutch, compared to areas in the South, such as Georgia, South Carolina, where turtles may have 1 to 3 eggs per clutch. However, those turtles in the South may have multiple clutches per year, whereas compared to the North, they usually only do 1 clutch per year. And yeah, I think I answered both of those.
And then related questions came in about hatch temperature and hatch duration.
What specifically about those?
Could I jump in and ask?
Yeah, please do.
Okay. In your slide, you said that the hatch duration is 80 days. But I misread, or maybe I misread, in your talk at the end, in your summary, you said the hatch duration was 80 days. But I thought I'd read in your slide that it was 68 days as the mean.
Oh, so the I believe the minimum incubation duration was 68 days, and the largest was 88 days. That was the mean between those two. It's 80. So between those range of values, and then the standard.
So it was 80 plus or
days.
minus 8 days, which
Yes,
makes
sir.
it so it makes it 72 days.
Yep, that would be a mean with the standard deviation.
So the question is, I breed spotted turtles, and my period is 60 days. So if I'm hatching them at a higher temperature, that might mean that they're hatching more quickly.
Yeah. That
so
certainly could be.
Supplementary question then to you is, what was the sex ratio of the animals you saw in the wild?
So it varied from study to study, but for my master's thesis study, we were mostly finding females, because we were going out and doing these nesting surveys where we were looking for actively nesting turtles. So most of them were females that we caught. However, if we were to go and put traps out, we'd probably get a more even distribution of males and females.
Okay, thank you for that.
Certainly.
So the other question I think that we didn't get to was about the range of the turtle. Do they move around a lot, or do they stay in one place? And then finally, a question has just come in. Have you ever seen a spotted turtle without the spots?
Sure. So the spotted turtle home range does vary significantly based on the habitat that they're in. There's some good habitat work and home range research by Scott Buchanan that you should check out, and their responses to early successional habitat change. But so they could have a home range of something like 20 hectares to up to like 103 hectares, and they do move sometimes to get to nesting sites. So females usually have a little bit larger home ranges than the males do, where the males usually have an area and they're just hanging out there. Younger males may go into different areas and look for different populations to hang out in. And yep, so it does vary between habitat and between sexes based on the literature. And then, yes, I have observed several spotted turtles with no spots on their carapace. And, you see that and you're like, well, that doesn't look right. And they may look like a bog turtle because that's one of their close relatives. However, they're lacking that orange patch on their neck to describe them as a bog turtle. But yeah, I have seen some of these spotted turtles without the yellow spots. And whenever you see one of those, you're like, wow, this is quite interesting.
Thank you, John. That was really informative. That was, you brought a wealth of original research to the table. There's a lot for us to sort through and think about in days to come. Thank you so much. Anything else before we wrap things up?
Oh, no, I just wanted to say thanks, and I didn't realize how much time I took. So yeah,
No,
thanks
you're
for having
good.
me.
We like, if you think about the turtle has 100 years and we only have like an hour and a half. So, it's all about perspective.
Yeah,
Appreciate that.
definitely.
Yeah, it was a lot. No, it was great. And this will go up on our YouTube channel, as I mentioned earlier. So I'll send you that link and folks can go back and go through this again and refresh some of the things that we may have overlooked. Thanks so much. Really appreciate your time. Happy New Year to everyone. We'll see you soon. Take care. Thanks so much.
Thanks a lot.